for these examples, we're given an integral, and what we want to do is we want to construct the geometric shape of it. Right? We want to sketch the graph, and we want to see if we can use facts from elementary geometry to figure out what that integral is without having to resort to limits or anything like that. So we're kind of going the opposite way of what we normally do. But there's a lot of value in this. It teaches you not to work any harder than you have to. So the first one is 2 dx. So 2 is a constant function. That means it's always a flat line of height 2. And it says that we're going from 0 to 3. So what I'm going to do is I'm going to draw this. I'm going to say 0 to 3. And then this is of height 2. So what I get is a rectangle with width 3 and height 2. So that tells me that this integral has a value of 6. Simple enough, right? The next one's a little more challenging. We're going from 0 to 2, so at least we're going from 0 to something. It's not too bad. Let's not use black, let's use red. But it's 2x plus 1. So that means I go from 0 to 2. And when x is 0, by the way, this should have a dx on it. So when x is 0, 2x plus 1 is at 1. But this is a line with slope 2, so when x is 2, 2x plus 1 is 5. So I actually have a trapezoid. I have a trapezoid which has height 1 on this side, which has height 5, and which has width 2. So if you remember how to find the area of a trapezoid, there's a couple of ways. One is to cut it into a rectangle and a triangle. That's fine. The other way, which I like better, is that you take the average of the heights and then you multiply it by the base. So you take the average of these values and then multiply it by the base. That's a very straightforward way. So in this case, you get 6. Well, looky there. Isn't that kind of neat, right? Purely accidental, I'm sure. So, what do you think? What do you think the chances are that's 6? Taking bets. So, in this particular case, we're going to go from -1 to 1. Now, this is a little more challenging, though. So, what might be useful is to think about what would this graph look like. So if I say y is the square root of 1 minus x squared, then it is also true that y squared is 1 minus x squared. Then putting all of the letter terms on one side, I get x squared plus y squared equals 1, which is the equation of the unit circle. However, notice that we're dealing with the case where the y value is positive because this is the positive root. So we don't actually have anything below the axis. We only have the semicircle. So the area in this case is 1/2 times the area of the regular circle. Which is pi r squared over 2. Now, in this case, it looks like the radius is 1. So the area in that particular case is pi over 2.